Welcome back to the Comptia Network Plus course using the Address Resolution Protocol. The Address Resolution Protocol ARP is part of the TCP/IP protocol stack. It's used to translate TCP/IP addresses to MAC addresses using broadcasts. When a machine running TCP wants to know which machine on an Ethernet network is using a certain IP address, it will send an ARP broadcast that says, in effect, hey, who exactly is IP xxx.xxx.xxx.xxx ? The machine that owns the specific address will respond with its own MAC address supplying the answer. The machine that made the inquiry will respond by adding the newly gained information to its own ARP table. In addition to the normal usage, the ARP designation refers to utility in Windows that you can use to manipulate and view the local workstation's ARP table. The Windows ARP table. The ARP table in Windows includes a list of TCP/IP addresses and their own physical MAC addresses. The table is cached in memory so that Windows doesn't have to perform ARP lookups for frequently accessed TCP/IP addresses like those of servers and default gateways. Each entry contains an IP address and a MAC address plus a value of TTL that determines how long each entry will remain in the ARP table. Remember that the ARP table contains two kinds of entries, dynamic and static. Dynamic ARP table entries are created whenever the Windows TCP/IP stack performs an ARP lookup but the MAC address isn't found in the ARP table. When the MAC address of the requested IP address is finally found or resolved, that information is then added into the ARP table as a dynamic entry. Whenever the request is sent, a packet to the host is sent to the data link layer. The ARP cache is checked first before an ARP broadcast is sent out. Remember, the ARP request is broadcast on the local segment. It does not go through a router. Using the Arp Utility. You know that ARP is a protocol included in the TCP/IP suite. You also understand that ARP is used by IP to determine the MAC address of a device that exists on the same subnet as the requesting device. When a TCP/IP device needs to forward a packet to a device on a local subnet, it first looks in its own table called the ARP cache or a MAC address lookup table for association between the known IP address of the destination device on the local subnet and that same device's MAC address. The cache is called that because the contents are periodically weeded out. If no association that includes the destination IP address can be found, the devices will then send out an ARP request that includes its own MAC and IP information as well as the IP address of the target device and a blank MAC address field. Filling in that blank object of the whole operations, it's the unknown value that the source device is requesting to be returned to it in the form of an ARP reply. Windows includes a utility called ARP that allows us to check out the operating system's ARP cache. To view this from a DOS prompt, use the ARP command like this. C users Tamil ARP displays and modifies the IP to physical address translation table used by Address Resolution Protocol. ARP-SINT AD or EGHAD or IFADD or ARP-DINT ADD or FADD or ARP-/AINT ADD or -N IFADDR-V. Table 17.2 describes the various options that you can use with the ARP command. I'll just go through them quickly. -A displays the current ARP entries by interrogating the current protocol data. If INTADDR is specified, the IP and physical addresses for only the specified computer are displayed. If more than one network interface uses ARP entries for each ARP table are displayed, the same as -A. -V displays current ARP entries in verbose mode. All invalid entries and entries on the loop back interface will be shown. INTADDR specifies an internet address. -N displays the ARP entries for the network interface specified by IFADDR. -D deletes the host specified by INETADDR. INETADDR may be wildcarded with star to delete all hosts. -S adds to host and associates the internet address INETADDR with the physical address ETHADDR. The physical address is given as 6 hexadecimal bytes separated by hyphens. The entry is permanent. ETHADDR specifies a physical address. IFADDR, if present, specifies the internet address of the interface whose address translation table should be modified. If not present, the first applicable interface will be used. Looking at the output really makes me wish we were all just running IPv6, because as you already should know, IPv6 doesn't need ARP, as well as many other annoying features and protocols required when running IP version 4. Of note, the Windows ARP utility is primarily useful for resolving duplicate IP addresses. For example, let's say your workstation receives its IP address from a DHCP server, but it accidentally receives the same address that some other workstation gets, and so when you try to ping it, you get no response. Your workstation is basically confused. It's trying to determine the MAC address, and it can't, because two machines are reporting that they have the same IP address. To solve this little snag, you use the ARP utility to view your local ARP table to see which TCP IP address is resolved to which MAC address. To display the entire current ARP table, use the ARP command with the -A switch, like so, to show you the MAC address lookup table. So here's the output from the -ARP command. Now from this output you can tell which MAC address is assigned to which IP address. Then for static assignments you can tell which workstation has a specific IP address, and if it's indeed supposed to have that address by examining your network documentation, you do have the record right. For DHCP assigned addresses, you can begin to uncover problems stemming from multiple DHCP scopes or servers, doling out identical addresses and other common configuration issues. And remember that under normal circumstances you shouldn't see IP addresses in the ARP table. That isn't a member of the same IP subnet as the interface. It's good to know that in addition to displaying the ARP table, you can use the ARP utility to manipulate the table itself. To add static entries to the ARP table, you use the ARP command with the -S switch. These static entries will stay in the ARP table until the machine is rebooted. A static entry essentially hardwires a specific IP address to a specific MAC address, so that when a packet needs to be sent to that IP address, it will automatically be sent to that MAC address. Here's the syntax. So here you can see is the output here. So ARP minus S IP address MAC address, simply replace the IP address and MAC address sections with the appropriate entries, like so ARP minus S 204.153.163.5. It's the MAC address 00 A0 C0 ABC311. Now let's take a look at your new ARP table by using the ARP-A command. You should see something like this: internet address 204.153.163.5, physical address 00 A0 C0 ABC311, type static. Finally, if you want to delete entries from the ARP table, you can either wait until the dynamic entries time out, or use the -D switch with the IP address of the static entry you'd like to delete, like this: ARP -D 204.153.163.5. Doing so effectively deletes the entry from the ARP table in memory. Using the nslookup utility. Whether you're configuring a server or a workstation to connect to the internet, you've got to start by configuring DNS if you want name resolution to happen. That is, if you want to be able to type www.cibex.com instead of the IP address. When configuring DNS, it's a very good thing to be able to test what IP address DNS is returning to ensure that it's working properly. The nslookup utility, you query a name server and quickly find out which names resolve to which IP address. The nslookup utility comes with Windows NT and later, as well as most versions of Unix and Linux, but not with Windows 95 and 98. You can run it from a Windows command prompt. At the command prompt, you can start the nslookup utility by typing nslookup and pressing enter. When you're inside this utility, the command prompt will change from something to a C/colon sign to a shorter sign. It will also display the name and IP address of the default DNS server you will be querying. You can change if necessary. Then you can start using nslookup. The following output gives you a sample of the display after the nslookup command has been entered at the C prompt. C users Tamil lookup, default G&T, corp PDC1 global net.local address 10.100.36.12. The primary job of nslookup is to tell the many different features of a particular domain name, the names of the servers that serve it and how they're configured. To get that, just type in a domain name at the prompt and the nslookup utility return this information: laml.com, server DSL modem domain.act DSL TMP address 192.168.0.1. The non-authoritative answer is as follows: name laml.com address 206.123.114.186. What this tells you is that the server that returned the information is not responsible, authoritative for the zone information of the domain for which you requested an address, and that name of the server for the domain laml.com is located at the IP address 206.123.114.186. You can also ask nslookup for other information by setting a different option with nslookup. Just type the option at the prompt and replace the option with the actual option you want to use. For example, use the set type equals mx to determine the IP address of your email server. If you can't decide which one you want to use the question mark at the greater sign to see all available options. If you type in nslookup and receive the reply, ns request timed out, timeout was 2 seconds, can't find server name for address 206.123.114.186, timed out, default server unknown, address FEC0 00FFFF:1, then you know your DNS servers are not answering. You need to get over to the DNS server stat. So I'm going to here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.